This is lesson 2 in chapter 3 of physics 30. Here in this chapter, in this lesson, we're going to talk about centripetal acceleration, which is the main topic of circular motion. Centripetal acceleration, imagining swinging a pail of water. If you've ever done this, grabbed a bucket of water and swung it around over your head, you'll notice that if you do it quick enough, none of the water is going to fall out. The question is why? Simple answer, centripetal acceleration. More technical answer, we'll see in a little bit. So with centripetal acceleration, we have three different equations to work with. We've got the first one, A equals v squared over r, where v is equal to velocity. So we have the acceleration will be velocity squared over r being the radius of the circle. So if you're swinging a pail of water, you would be considered at the center of the circle, and the radius would be from your center point to the bucket of water. The second one, acceleration is equal to 4 pi squared times r, again the radius, over t squared. T in this equation is the period, which means the amount of time to complete one revolution, the amount of time to complete one full rotation in the circle. And the third equation, acceleration equals 4 pi squared rf squared. R again is the radius, and f is the frequency, meaning the number of revolutions or the number of rotations through the circle in 1 second. So, reviewing the four formulas that we know force is equal to mass times acceleration, and then we have three different acceleration formulas, which means that we can just put this together. And we can replace the acceleration in this first F equals ma. We can replace this acceleration with any of these other three accelerations. So if we do that, we end up with this for red, that the force C, Fc, C standing for centripetal. So Fc would be centripetal force would be equal to mv squared over r. Centripetal force could also be equal to m4 pi squared r over t squared, or centripetal force could be equal to m4 pi squared rf squared. You don't need to necessarily be using all of these. It's going to be dependent on what the question tells you. So if you're given velocity, you're going to use the equation that uses velocity, obviously, hopefully. If you're given period, you're going to use the green one, which deals with t being the period. And if you're given frequency, then we're going to have to deal with this purple one, which is the only one that relates frequency at all. So looking at an example, what is the minimum time I can swing a pail of water in a vertical circle of 1.2 meters and keep the water in the pail? Well, let's see. When the bucket is upside down, we will have the force of gravity trying to pull the water out, and we'll have the centripetal force keeping the water in. In order that these two balance out, and so that the water does not fall out, centripetal force would have to be equal to gravity or greater. So we will look for the point where they are equal. We are given that the radius is 1.2 meters squared, and we are looking for t, because we want to know what's the minimum time, so we want to know what is that period of that function. We know for the water to not fall out, centripetal force must be equal to the gravitational force, so Fc must be equal to Fg. Since we're looking for period, we need to pull in that equation, which said m4 pi squared r over t squared, and that's going to be equal to gravity, which we know gravity is still mass times acceleration, or mass times the acceleration of gravity. So we notice that we have mass on both sides of this equation, so we can simply divide both sides by m to cancel them out. And then we can also divide both sides by cross multiply, divide both sides by g and multiply both sides by t squared to get this equation. Once we're there, we can simply plug in that gravity is 9.8, our radius r is 1.2. So we end up with this equation, and calculating it all out, remembering to square root your final answer, we get that t, the period, will be equal to 2.2 seconds. At what speed is a pail of water moving in a vertical circle of 1.2 meters if the water stays in the pail? So key word here is the speed. That would be, we would be thinking velocity. So we know that we're going to need to use the velocity equation at some point. Again, we have force of gravity and centripetal force working against each other. The radius is still 1.2 meters, and we want to know velocity. So again, setting centripetal force equal to gravitational force, we now pull in our velocity formula, which says mv squared over r, and that's going to be equal to gravity, which is again mass times the acceleration of gravity. Again, we have mass on both sides, so we can simply divide both sides by m. And since we're looking for r, then we can just multiply both sides by, since we're looking for v, we can multiply both sides by r to get v by itself. We can plug in 9.8 for g and 1.2 for the radius. Multiplying that and then square rooting, we find that v will be equal to 3.4 meters per second. So regardless of the mass, meaning doesn't matter how much water there is, it could be a tiny drop of water, could be a huge amount of water, but regardless of how much water there is, you're going to need to spin it at 3.4 meters per second in order to keep the water inside the bucket, which may seem counterintuitive, but yes, no matter how much water there is, the speed to keep it inside the bucket is the same.